Hi, Sodaites, and welcome everyone to the first Soda Social Computer Vision in Production special. For those people who don't know me, my name is Anthony Kelly, and I'm a principal recruitment consultant with Trust in Soda. This is our very first of our continuous series on the topic of computer vision, where we will talk about computer vision in production. We'll be hitting all topics from your full stack computer vision engineering to your hardware, robotics, GPU clusters, edge devices, OpenCV, LiDARs, cameras, you name it. So the future for computer vision technology is going to be huge. The industry alone is anticipated to be worth $28 billion by 2030. Even right now, we're not even capable of understanding how different that's going to look by 2013. I don't even think our children in the future will have driving licenses. I think they'll laugh at the fact that we used to have to sit a test and that we used to have to get our picture taken, put in a little card to keep in our wallets to say, yeah, this shows that I can drive a car, when they'll probably never need one in the future at all. So look, we're not tackling that issue today. That's not the challenge that we're looking to solve. But I would like to introduce everyone who is on the panel. So our first panelist is Najib Van Schmut. Najib is the CTO and founder of Peregrine Technologies, and Najib holds a PhD from Heidelberg University in computer science, where she focused on computer vision applications in robotics and autonomous driving. Najib, it's great to have you on the meetup, and great to have you as part of the panel. So for those people who don't know too much about you, could you introduce yourself a little bit more and tell us what work you're doing with computer vision in production?
Sure. Thanks for the kind introduction, and Anthony, I'm very glad to be part of tonight's panel. Yeah, quick intro to myself. So as Anthony mentioned, I'm basically computer scientist by education and also holding a PhD. I think it's now over 10 years already that I'm working in the computer vision field. I started with robotics and applications, classical object detection, and got then more into localization and mapping, so SLAM related tasks, always in robotics environment, but then moved also more to automotive applications and especially autonomous driving. Worked for Bosch and TomTom in the past, so also one of the bigger guys here in Germany or in Europe anyways. It was super fun and interesting, but then I decided it's time to start something on my own. Co-founded Peregrine Technologies, and actually we still are in the mobility ecosystem, but we want to make use of camera technologies and perception technologies and all these things, and apply them already today and give benefits already today, and not wait until the streets are full of autonomous cars. That will still take a little bit more. So yeah, that's what we do. I think I can dig perhaps later also more in detail on what we actually do, and want to give maybe the opportunity now back to you and to the others to introduce themselves.
Yeah, sure. So next I'd like to introduce Furkan. So Furkan is currently a senior lead software engineer with X-Ray Labs in Germany, and he has worked as a postdoc fellow at the Department of Computer Science in OMA. Furkan, same question. Give us a little bit of an introduction to yourself and how you're working with computer vision in production.
Yeah, sure. Thank you very much for the introduction. Yeah, I actually did my PhD in 3D computer vision plus 3D computer graphics. So we got from South Korea in 2014. So we got a very interesting project at that time, the development of infrared scanner that is based on 3D computer vision, but a lot of image processing as well. So I was developing a novel device that was not actually existed at that time. Only 3 devices existed. So based on that, my experience, then I joined the Hyundai Motor, where I was developing a 3D inspection system and for car motors. And then because I worked a little bit during my PhD with medical doctors based on this computer vision kind of application. So based on that, I actually went to Berkeley, where I did the medical injury kind of background, dynamic recruitment, musculoskeletal modeling, mapping of 3D motion capture data to my MRI data. So all these background actually I'm implementing in this company now, where we provide very innovative kind of solution to these big giants like automobile industry and electronics industry, where we do 2D and 3D inspections, for example, detection of cracks, porosity analyses, and these kind of things. Yeah, so yeah, that's it. And then we can move further, and then you can have any question then.
Yes, perfect. And then next, if we want to introduce Evgeny. So Evgeny is a research engineer at Zalando, where he's been working on the size and recommendation team. Evgeny has a PhD in applied maths from the Immanuel Kant Baltic Federal University. So Evgeny, look, same question to you. Would you like to introduce yourself a little and tell us the computer vision application production that computer vision you're working on in production?
Hi everyone. It's thank you for the invitation. It's great to be here. So yeah, I also have kind of some background in robotics and autonomous driving while I was at the university. My professional career kind of started from general software development, and then I transitioned toward machine learning and computer vision development, and among past projects were building, for example, optical character recognition engine and unsafe and violent content detection system, selfie style transfer. My latest experience is within Zalando, which is an online fashion platform. I'm there part of Size and Fit team, where we try to solve a pretty challenging topic, I would say, around it's not just predicting the correct size for customers who shop online. It's really more complicated, and my job there is not around computer vision, but more about any kind of machine learning related problem and kind of pipelining it and converting research into a product. And I'll be happy to tell more about the challenges that we experience while solving the size prediction and fit prediction, and how the online fashion future could look like. So yeah, I look forward to it. Thanks.
Excellent. Thank you, Evgeny. And last but not least, we have Depti. So Depti is a machine learning engineer at Merantix Labs, and there is where she focuses on computer vision topics. She's a recent graduate from TU of Stuttgart with a master's degree in information technology. So Depti, again, look, same question. Could you tell us a little bit more about yourself and the work you're doing with computer vision in production?
So, thank you, Anthony, for this invitation. And hello, everyone. I'm Deepthi. So as Anthony said, I'm working as a machine learning engineer at Merantix Labs. So a little bit background about my company. So we at Merantix Labs position ourselves as an external machine learning department for our clients. So we help our clients in ideating and identifying an AI use case, which will have them highest business value. So we collaborate with them in data collection and labeling, and also create a successful prototype for them. And we also help them in scaling these solutions. So the industries that we focus on are mainly related to manufacturing, logistics, services, healthcare, retail. So yeah, there are quite a lot of computer vision applications that we have worked on, and would be happy to share them in the talk. Thank you.
Excellent. Thank you. And thank you everyone for giving those introductions. It's great to see 4 panelists with strong computer vision backgrounds, but also coming from each individual industry in computer vision. So yeah, I suppose, look, if we start off and talk a little bit about the applications of computer vision within your company and how you're using computer vision to solve the challenges that your business is addressing. If we start off, actually, Evgeny, you know, if you want to start off first and tell us a little bit about the size and fit, where computer vision fits in. And look, first off, I know personally the challenge in fashion is almost 50% of products if I'm right, it could in and around 50% are actually returned due to wrong size, and it's a lot of money to receive these goods and also send back out new goods, delivery and shipping alone. But yeah, tell us a little bit about why you are using computer vision first off, and where it all started.
Yeah, that's true. The size-related returns are a huge issue and cost a lot to the company. And there was some global marketing analysis that if online fashion could reduce the size-related returns just by 10%, that could force the companies to reduce the price by 20%, for example, which could be a tiebreaker. So that's a huge problem. And online fashion is not restricted just to size and fit. At Zalando, we have a really wide range of computer vision problems that we're solving. For example, I could start with kind of major application or tool that Zalando research department has built and is heavily used inside the company, which we call Fashion DNA. It's basically encoding neural network that takes item images and some metadata about the articles and tries to build an encoding that is kind of separates that has a meaning. It's similar to word2vec and other word sentence level encodings, but for fashion basically. Well, maybe I can share a bit some images to bring more context. Just a second. Do you see my screen?
Yeah, we're good. We can see.
Yeah, great. So, for example, this is how the embeddings could look like on a plane, and you see that these embeddings, they learn something meaningful because different types of garments, they appear in different space here, and that allows us to solve a lot of downstream tasks. For example, just a similar item recommendation problem is solving this task not just based on past purchases or current browsing experience of a customer. We also use the item customer, the embeddings of the items customer browsed through as one of the features to the prediction model. We also use this embeddings just to predict the outfit. We can generate outfits. For example, for this jacket, these trousers, this t-shirt fits well, and these shoes, they don't fit well. We also have, it's running actually live, the prediction model that kind of recommends the outfits for the garment that you're looking at the moment. We also have a very strong kind of research department that works in direction of image generation, where we kind of trying to, for example, one of the applications could be basically is to automate fashion design. The typical generative adversarial networks, they work in the way that from some random distribution, you generate an image. And here we want to control this somehow, control different properties of the items. For example, we can have a shape that we would like to control, but we want to change the texture or the color. And we've published several papers around this conditional image generation approaches that allows us to do that. And this kind of in the futures could help to speed up the design process. One of the directions is basically showing how you could look like in wearing this or that item. And we also find an application for GANs here. For example, the same pullover, we could try to fit it on different models. And we could try on the other way, we could try to fit different items on the same model, or we could change pose for the model. This kind of tasks, they are more experimental, not production at the moment, but they allow to think and project how this online fashion experience could look like in the future. Regarding this size prediction, I could share one of our latest research that got published last year, as I remember, where we used images that we have at our content creation station. Basically, it's a shooting laboratory where we should take high quality pictures of every item that goes to our website for sale, with models and without models. So we have these images coming in. And what we would like to do is basically just looking at this image before any first purchase or return of the item. We want to predict, is this going to create size issue or not? Because typically you usually rely on purchase history and a return history, and from this behavior you can build several statistical models and recommend that this items is too big, this one is too small, we recommend you this or that size. But that requires to aggregate some purchase history before. But so we're trying to solve this and to raise what we call a flag of a size issue even before the first purchase. And we build it in a kind of teacher-student approach, where we have a statistical model that basically works on this purchase history and return history. And this model tries to teach a student deep learning model to predict the size issue from the image. And it works quite well. It's now, we use it in production and it kind of predicts, it's used as a prior to this statistical model, and we're kind of predicting. Here we visualizing the heat map and trying to understand what this network thinks about, what kind of areas of the garment causing the size issue. And at some pictures it looks like it makes sense. For example, here you see that it's the sleeve area of the jacket is more red, so we might think that too long sleeves could cause some size issues, or too tight waist area here on the jeans could cause size issue. So there are just a few examples. Maybe we could dive deep in certain areas if there are more questions.
Yeah, so in terms of Q&A, we will leave some time at the end, Evgeny, for those in the audience to ask questions. But I suppose, look, if we take it on now, and if we want to jump over to yourself, Deputy, if you want to tell us about some of the computer vision applications that you're using at Merantix, and then even more specifically, if you want to talk about the computer vision applications at Merantix Labs as well, that would be fantastic.
Yeah. So like I said before, Merantix Labs are mostly focused in different sectors. So like manufacturing, logistics. So some of the computer vision projects that we did for our fashion retailer client is quality control. So here the problem statement was to review the package, the returned package, whether it can be resold or to check if there is any defect or not. So here we built a visual classifier which will automate this process. And we're also looking to scale such solutions to other manufacturing industries to check the conformance of the finished product, the final product. And in healthcare sector, for one of our clients, we've done a project related to skin disease classification. So here, the images from the skin biopsies, which are the microscopic images, which are usually large. So we divide them into several small patches and do a kind of multi-instance classification. So these are roughly some of the examples of computer vision applications or projects that we deal at Mirantix Labs.
Fantastic, fantastic. And now, if we want to jump over to Naja, how about you? How are Peregrine using computer vision in production? What's going on with you?
Sure. As I mentioned earlier on, we are in the automotive space, and what we actually do is that we put cameras behind the windshields of commercial vehicles. And then basically the software powering these cameras is analyzing at the spot, basically while driving, all the image materials, and the software we write is understanding the scene, the context of the situation, so what is happening, where are all the traffic participants, how are the distances, what are the traffic rules, is there signs or traffic lights I need to take care of, and all these, basically, data describing the situation, we then provide to our customers, and with this very actionable insights, we help them to improve their services and their offers, basically. So what we have is quite a mixed pipeline of different things. So we have some what I would call more classical computer vision topics, like, I don't know, feature tracking, matching. We have kind of things related to SLAM and 3D reconstruction to really understand, to go from the imagery to the real world, and then metric information and distances and so on. And of course, we have also a lot of machine learning applications within to differentiate different objects, to say, is there something novel in the scene? Is there something we never seen before? To classify different kind of situations. And what is super interesting, that actually it's kind of a mix between a lot of stuff running directly on the device. I mean, to make this instantaneous decisions and analytics, but then also, of course, if it's more in regards to training new models, then we have, of course, some also offline processing parts. But so yeah, all in all, it's all about computer vision with us.
Nice. And now, finally, Furkan, if you wanna tell us about how you are working with computer vision in production at X-Ray Labs.
Yeah, sure. As I told you, we provide industrial solutions. Basically, we provide solutions in inspection. So when you talk about inspection, you actually involved in computer vision kind of fields, because you have to take the images of the product or whatever the industry wants. So what we do is, basically, when we talk about the 3D inspection systems, the 3D inspection solutions, we have to scan the 3D model. When the company actually wants to inspect the surface of some model, we have to scan it. So in-house, we develop a 3D scanning system where we actually scan the model and then inspect the surface, whether the model is good or not. And if you talk about the 2D inspection, so we also provide the inline solutions to the industry, where we have to classify our segment, maybe the outliers in the images. Suppose in the inline systems, you identify different objects and then you classify in a certain category. So you have to install the cameras and you have to do some kind of computer vision kind of processing to inspect those parts. And we also actually, because we also develop solutions for X-ray machines. So because we do X-ray inspections. So in X-ray inspection, you also have to inspect the electronics parts as well as the industrial parts, maybe the aluminum part as well, not even just a plastic. So we do the internal porosity analysis if there is an outlier or there is an internal crack in the model. So we classify our segmentation, this kind of using these latest AI techniques, machine learning, because the company or the clients would have a lot of data, so we can actually train our model to detect different certain parts or different kinds of detects, not even single detects. Some parts would have 20 types of different defects or cracks or internal voids in it. So we have to use these machine learning models based on their data, and we also create our own data because we have the X-ray machines. We can do that. So we actually provide all this kind of innovative solutions to the companies, and we also develop the in-house software where software that you can do some wide analysis. You can also have the software you can do in your own company. So yeah, I would be happy to answer anything relevant to even medical images, because I am also background medical images, and you know that medical images experience same used in the X-ray images. So it's a little bit similar to the 3D reconstruction and this whole pipeline of 3D computer vision and you know this X-ray medical images as well. So I would be happy to answer any question.
Excellent, Furkan, thank you. And if anyone does have any questions now that they would like answered at the end, feel free to put them into the Q&A or into the chat, and we can hold off until asking them for the end, or you can either wait for 20 minutes until the end of the podcast to go ahead. So my next question is almost in the area of a data scientist, machine learning engineer's nightmare. It's on the question of data privacy. Particularly in Europe and in Germany, these rules are a lot more strict than the rest of the world. Recently, everyone's obviously familiar with GDPR, in particular with machine learning. Now that you have these machines that are autonomously learning, where do they stop? Is, I suppose, if you think of the media is obviously telling everyone that the machines are just going to learn everything about us. There's going to be no stopping to them. But in reality, you know, these are supervised machine learning models, or machine learning models that are fully autonomous and have restrictions in them to make sure that they're compliant, or I suppose that you would say explainable AI. So I suppose if we want to start off with Najib, do you want to tell us about the data quality issues, or I suppose anything around data privacy that you feel is the biggest challenge to the autonomous driving industry at the moment?
Yeah, sure. I mean, that's a very, very big topic, I would say,
Where
and
to
very
start?
important one. Yeah, where to start? That's the question. So, you know, if you especially have, like, as we also do, and actually all autonomous cars or all driver assistance systems in cars face these problems. If you put a camera in a car and you basically film or capture image from outwards, you always see personal information which you need to treat very seriously. I mean, that is faces, this is license plates, these kind of things. And obviously you can't ask everyone you see for consent. So that is why you need to treat this very, very seriously. And I mean, of course, there are two things. The best thing you can do, and that is actually the approach we also try to follow as much as possible at Peregrine, is to actually evaluate all the data directly at the camera, and then basically just keeping this extracted meta information, basically the understanding of the scene, right? I mean, for example, we extract or detect there's a person, then we have, I mean, if you want to keep it simple, then you have basically a bounding box just saying there's a person with this size and this information you can store, and that is anonymized, or you can't trace it back to a specific face or person. The same you can do for cars and so on, right? So that is good. But if you actually, in a lot of cases, you also need the image material itself. If you want to train your networks, improve your models, you need some real data. And actually then you really need to consider how can you anonymize these information so that you remove any personal information. There are some tricks and fancy things you can do with guns to generate artificial faces or license plate, or you can just blur it away, but you always need to make sure, or also other things you can do. I mean, yeah, depending on what you actually want to do with it. And I mean, that's then also perhaps in the point of data quality you mentioned. how do you want to use this data then further? For example, if I want to train, I probably can't blur an image or face away, because then the model will probably learn that faces are always blurred, which is not so good, and these kind of things. So yeah.
Yeah, it comes down to perception, but it leaves me with a question to ask at the end. And I'll have to remind myself, but I'm quite interested in understanding the value, or how do you have to be so efficient with a model that's going to run like that, that you'll actually see value from the model, because it's obviously going to cost a lot of money and time to solve that issue. So then if we kind of jump into Evgeny next, if you want to tell us a little bit about the data quality issues that users are facing, particularly around Zalando and sizing, and then how users are looking to solve them.
Well, yeah, GDPR has been recently a big topic, especially in Zalando, because we have a lot of personal data that we need to take care of. Well, if we restrict this just to computer vision problems and to images, then maybe it's not that bad, I would say, because we're not taking customer images, for example. Yeah, it's more around our content creation. So we're shooting models wearing our clothes, and if they kind of want to be forgotten, they have a right for it, and we should have methods in place that could take care of that. But another interesting topic that rises within the company is around algorithmic privacy and fairness, and then sometimes it's kind of forgotten. So it's not just that we remove the data that is stored, it's more about this data was used before in some model, deep learning model that produced some embeddings, and if you improve it over time, if you kind of retrain this model with new data, then the previous data that customer consented to be deleted is kind of still there in form of some numbers, embeddings. So it's kind of hidden, but it still affects the way the model performs now. And this is still a tricky topic. I encourage you to take a look at the book Ethical Algorithm, as I remember, that touches this problem. So it's like how you ensure that your algorithm is not using the data that has to be deleted, and that is fair, there are no biases in it, and investigating models for biases is like a huge direction. This is still under research. And yeah, so I would say, comparing to autonomous driving, the computer vision related privacy is not that big of a problem in Zalando, but still, for example, in our case, for this algorithmic privacy, we're kind of using the customer journey histories, how they browse, how they walk through the website, to train some recurrent models to predict recommendations, for example. And then the next day, we don't train this model from scratch. We train it from the previous state. And this is a problem, yeah. So we need to ensure that the data, that is not, the purchase history of this particular customer is already deleted, but still there are some, yeah. It's I think you understand where I'm going at.
It's jumping into a big rabbit hole from there on in. But look, we can touch in that on the Q&A, which is great. We're starting to already see some questions come in. Time to get a bit interesting. If you want to head over to the healthcare industry, Furkan, would you like to tell us about the data privacy rules and restrictions in computer vision that you're currently facing, and the challenges, and how that's also restricting you to build better computer vision products even?
Yeah, I had a first experience when I was actually taking my MRI. The project was from Siemens when I was in Berkeley. So to get that MRI data, that was a huge problem at that time because of this privacy kind of issue in USA. So if you talk about in healthcare, so I had that experience, and it took me 6 months to just get my MRI, and to because I needed a bone model for musculoskeletal mathematical model. So, and now when I got here, so it's a kind of not similar experience, but it's really hard kind of same issue that, for example, if the company actually send us the data, so we can't even see that data without even signing some documents. I mean, the data would be in our company, but we can't see that. So it's a same kind of things that the industry send us the images, and I have to train some model, but still actually they have to get a lot of permission from their own company, and a lot of, I mean, the huge hierarchy that they have. And then in the end, because if I get problem, I could solve the problem in just 2 weeks, but they need 6 months. So it's like that's why I think there is a delay in the technology, that some problems are taking so long to solve. I think because of this kind of problem, because a lot of problem actually comes from the military, and military sector. They try to solve these problems using this machine learning and AI kind of stuff, but they can't actually give you all those things. I was dealing one of the project that was from the military side. So that was the problem. I was actually solving that problem, and I was actually about to solve that problem. It was 90% was done. I was detecting some kind of outlier and cracks in the images, because we wanted to automate the whole process of a product. If it is a defectless, or it's okay or good, right? So we have to actually check like 20 kinds of defects and different things in that part. So I was about to solve it, but the problem was there was not okay from the company, because they could not actually share us whole data that they had. And that's I think problem, my
Yeah,
experience.
that's 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 a big restriction. It does give me a question though for a Q&A about, do you think synthetic data for computer vision is going to be an answer? But look, before we get into that, we'll move on to Depti. So Depti, same question I've asked the guys there in terms of data privacy rules and restrictions in your industry. Where has that seen you at Marantix Labs? How's that affecting you?
Well, as we all know that maintaining a good data quality is very much important for the model's performance. So one issue we often encounter here is the inconsistency in the data collection pipeline. So when the data is collected in different batches, it might result in say duplicate data, and the model does not learn anything new on it. And when the data is being collected at different times and often labeled by different annotators, then there can be some errors imposed there. So one thing we follow is to have a data pipeline to be more data collection pipeline to be more structured and more standardized, like to follow different standard camera settings or parameters, lighting, such things. And since this labeling is as a whole topic is an iterative process, we constantly review the data after it's being labeled, and also the whole process of this labeling is reviewed periodically. So coming to the privacy topic of data, like as you said, it's a big thing in Europe. So all of our data is maintained private, confidentially, and also our compute servers are European based. So we are very much in compliant with the European data protection regulations.
Excellent, thank you. And I see we've just hit the 40-minute mark now. So what I'll do is I'll just start answering some of the questions from the Q&A. So if you have them, anyone in the audience, feel free to send them over. So the first question is in from Renju. Renju asked an interesting question here, Naja. I'm going to leave it to you. It's how much stake does computer vision have in advanced autonomous driving? With the advancements in computer vision and deep learning, can 100% autonomous driving be obtained with just a camera? Now, this is actually very interesting. I spoke with someone last week or this week about it, and we talked about how the development of smartphones and camera technology due to smartphones has really helped this. And I suppose it's also more cost effective when you compare it to the likes of radar and LiDAR with the more traditional methods. But yeah, up to you, Naja, take it away.
Yeah, I mean, I guess it's also kind of a philosophical question. You know, I'm a computer vision person, so, and also if I compare it to humans, we don't have radars, we don't have LiDARs, or we don't have, I mean, we have our ears, which is basically kind of an IMU, or you can compare, we even don't have GPS or something, right? And we can still drive, and I would say drive very good and very reliably, and also manage all kinds of situations. We have two eyes, two cameras, so to have stereo and kind of the depth estimation and so on, kind of inherently. But so I would say, yeah, I guess theoretically it is possible to do that just using computer vision, but I think the way is still very long. I mean, it starts with that still our eyes from the reception and so are much better than today's cameras. If you think about darkness and other things, and of course our brain is much more capable at the moment at any neural network at the moment and so on. So I would say in theory it's possible, but it has also good reasons why we use LiDAR and radar and so on and so forth at the moment. Just also for redundancy, for security reasons, and because, I mean, if I can have a LiDAR, of course it's more expensive. Yeah, it directly gives me a very good 3D information, right? Yeah.
Nice. Next question is another question from Naja from Gigliamo. He's asking, automotive applications are deployed in the wild, so they're subject to malicious or casual adversarial attacks. Do you provide tools or facilities to explain the outcome of computer vision models in case of issues?
I mean, of course, we have internally some tools to deal with that, or to, I mean, I think I briefly mentioned it at the beginning. I mean, if there's something unexpected or novel, or we react on that, but we don't provide any tools, if that was a question, externally, that's not, at least not at the moment, to deal with these things. But I mean, yeah, these adversarial attacks and or malicious attempts, that is, of course, something serious and to deal with in the future. And probably will be more and more coming if more and more automation, I mean, not necessarily only in autonomous driving or all these things, but probably also in other areas, you will see it. So you need to think about how to deal with that.
Cool. Next question is from Amit. He asks, how do you deal with the challenge of AI on embedded systems while also keeping it near real time?
Is that again a question for me?
Do you know, is there anyone else that would be able to take that? I do get the feeling you're working with the most real time image data.
Yeah, I mean, I'm happy to jump on that as well. Of course, that's always a compromise to embedded and real time. Yeah, I mean, you need to compromise between the result. I mean, if I keep it to, I don't know, object detection model or so, of course, if you have more and more processing time, then you can run better and better models. The same is true for resource. So of course we have not at the moment the best kind of accuracy or of the models, but in many cases, and especially how we deal with that is that actually it's not always required to have the best model, but kind of I would say, a very intelligent way to make use of kind of different approaches and to make the most efficient use of the compute resources you have in order to mitigate some of these effects. But yeah, it's always a compromise and yeah.
Next question is from Martin. He has a question on big data acquisition, and he is wondering, is there any restrictions on how you could use customer personal data? I'm not quite sure if he means, is that the question, or maybe is there any restrictions on how you could acquire customer personal data? If you could just share a little bit more on that, Martin, that would be great. So I suppose for myself, I have a question for Furkan. So it's very important now, if you're trying to release a computer vision product to the market, that you're obviously hitting your industry standards, you're attaining a CE mark so that you can actually sell a product. Particularly in the medical and health industry, I know that's quite difficult because these can be 200-300 page documents. And a lot of the time, technical professionals aren't thinking about writing 200 to 300 pages of medical documentation to say, yeah, great, this is what our product does do and doesn't do. And then it also relates back to the explainable AI that you have to provide in your algorithm. In your opinion, what advice would you offer to anyone who is looking to obtain a CE mark, whether it be in healthcare or any other industry, and what would you tell them you've experienced?
Yeah, I think that's very interesting question, because they are one of my product that actually solves some kind of medical problems, and software is 3D Volvicom. It's a medical imaging visualization and image analysis kind of software where you do some kind of creation of 3D models for 3D printing and for some kind of segmentations. So when you talk about this kind of licensing kind of thing in Europe or in any country, I mean America and Pakistan, so a lot of people actually contacted me, and we had a little bit discussion on that. And I also wanted to do that if we manufacture and the whole solutions that is based on some software and then the physical product. So I did not really actually dig deep into this topic, but actually this is very much problem, because when I was dealing with the Korean doctors, they also actually said that it would be really difficult, just forget about that. And when I talk about my home country, Pakistan, doctors, they also said that, sorry about that. I mean, it would be really hard to get the CE mark or to pass this, the medical boards that you have to actually get approval from them. Then you can go for the CE kind of thing, right? So I am also actually looking for the right answer of this question. How can we go and how can we? But in my experience, it is very, very difficult for a guy who is not background from a medical, but developing a product for medical industry. So they are not that much means sure about that. Okay, whom to contact and what to do. So I mean, you get the idea.
It's almost like needing to speak two different languages.
Yes.
one being doctor or medical, and the other one being programming. But yeah, no, I do know, and one thing, definitely, I may be wrong on this, but I believe Vara are one of 3 healthcare companies in Germany that actually have a CE mark for medical device products using computer vision.
Yes.
Excellent. Next question is for Evgeny. It's from Junli. He says, how is the performance of sizing recommendation without any browser history?
I would, there are kind of 2 different products that could relate to this question. I'll try to cover both. So if we speak just about personalized size recommendation, that for this customer whom we know a bit from what they bought previously on our website. And for this particular garment that we also know a bit about, we recommend you to buy size 48, for example, right? For this type of recommendations, if we don't know any previous purchase history for this customer, then of course, yes, it makes the problem a bit tricky. And we are still investigating different approaches of how to get the kind of not sensitive, but kind of reliable information from the customer, how to onboard them to be able to provide them this kind of recommendations. And for example, if we ask them to fill a really big survey, including questions, what's your height, size, age, weight, this kind of really personal sensitive questions that you can get a pretty reliable model that predicts the size. But asking those questions, it's what customers don't like. They don't like this kind of questionnaires, especially because of the privacy concerns. And another approach that is less sensitive is just to ask what kind of brands you already wear, what you own, and what sizes of those brands you have. And this model is comparable to what we have so far. And in terms of percentage points, it's like from 75% of correct predictions, it could go down to 65, something like that. So it's solving the problem. It's better than random, and sometimes it's better than customer. We also did some research. It's better than what customers think would fit them. So we kind of also beating this baseline. So this model would be better than the customer themselves to predict the correct fit. And if we speak about the computer vision model that I've shared previously that tries to predict the size issue of the garment, the problem there is that there's actually no ground truth data. So we don't have a data that says this item has size issue, this item has not size issue. That what makes it complicated. So we try to infer the size issue from the statistical model of past return history. And we use this statistical model predictions as soft labels that are weighted by the percentage prediction, and they serve as an input to this model. So the only way we could judge of how good this model is basically to track the change of customer behavior. Do they return less? And actually they do. So there is a direct business impact. We reduced size related returns. I don't remember the latest numbers, but it's pretty, like, it's millions of euros of savings for the company. So this proved it kind of works, though there is no real ground truth data for that. I hope that answers the question.
Nice. Quick question from Benny: is any advice on image stitching for cameras at various angles? He hasn't directed it at anyone, so if anyone wants to weigh in.
Yeah, image stitching, I think it's a big problem when you talk about to reconstruct I think our living environment, and as well as our I think in our virtual kind of 3D environment. So there is one good news about that, because in stitching you have to do key point detection, registration, alignment, and then you have to do some kind of blending. And the hardest part is the key point detection and then registration. So there is a very popular algorithm, shift and serve, and there were commercial usage restrictions on the shift. But the good news is that the commercial restriction is over, because the patent, the time limit for the patent is over now, so you can actually freely use the shift. So I think you can, if you can have good results of this key point detection and then registration using some vision algorithms, I think then the problem could be easy. Yeah, that's what I can think of.
We've got 3 more questions.
I'm sorry, actually, I was actually just explaining one example that I was dealing with. So we have the customer actually sent us a very long kind of wires because they have to inspect internally from the wire. So automobile industry actually send us a long wire, suppose that 2 meters wire. So we have to actually get the X-ray scan of the wire, and we cannot have the 2 meters X-ray scan, so we have to have the in patches. And when we get the patches, we have to stitch them together, right? And then we can see the whole wire in one image. So the same kind of actually, I mean, that was not different angles, but I use this kind of same techniques, and I think I get some nice results. But I'm not sure if yeah, I think Naja is expert on this SLAM kind of thing. Then if you map that SLAM, I think the location mapping, then I think it's doable.
Nice. So we'll get through the next ones hopefully as quick as we can, because I think we're going to jump into some breakout areas after 6 p.m. So with the advanced deep learning methods available, are OpenCV methods getting outdated, or are they being used in machine learning or computer vision applications? That's a question from Jitesh. It was an open question. Apologies if anyone would like to jump in on that. Maybe Deputy, if you'd like to jump in first.
Yeah, sure. So I think like even though there are like advanced techniques in deep learning, we still use some of the OpenCV methods for, say, data pre-processing or post-processing. So it's still not like outdated completely, but it's getting on that way, I would say. And in maybe in few more years, like once there are some advanced techniques in deep learning, then the traditional OpenCV is completely ruled out.
Excellent. We'll try and get as many in as quickly as we can here then as well. So question from Moses Wong, again, not directed at anyone. So whoever feels like they can take a go with it if you want to jump in. Is that how do you deal with situations where there is not enough images to train a computer vision model? Would transfer learning be the main way to go? And how often do you use transfer learning if you do? Or if you have any other strategies such as synthetic image data, what would you be going to? What would your go-to be? Anyone want to take that one?
I would add a bit. Besides transfer learning, there is a big area of research in self-supervised and unsupervised learning. Then there is weakly supervised learning and the zero-shot learning. Like these techniques, they try to solve this problem of learning from little data, and I think it's kind of the future, especially like if we want to try to build models that learn as effective as humans. This is the way to go, because we humans and driving, as Naja said, is one of the cases. We learn to do this task pretty quickly, and in our lives there are just 1 or 2 examples are enough to capture particular pattern, not to touch hotspot or something, and so learning from very few samples. This is still an ongoing research in the academic community, and I would expect some advancements there that could significantly improve the whole development and would allow to appear many more other applications, because right now deep learning is really data heavy, data demanding.
So just from my side, I know 2 other potential solutions. One is people are also crowdsourcing data, which has been quite successful. I can't remember the website, maybe one of you guys can, but you can actually search it. And then I did speak with an interesting startup who are still in stealth mode at the moment. They are looking at building synthetic doubles. So it could be the case that we could use image data for synthetics very soon. We'll go through the last few questions before we jump into the breakout area, just so nobody was left out. So if we can hold off on the questions. First question is from first of the final three is from Laura. It's a question for everybody. As Jenny mentioned, bias is a problem. How do you identify and deal with bias? Is there any particular challenges or problematic cases that you've had to solve? Anybody want to jump in there?
If you don't mind, like I could say that requires a lot of data analysis. So you have some data you use for training. If you want to, like, everything starts with the data. If you put in garbage in, garbage out, basically. So you need to be sure that there are no biases in your data, and therefore there might be no biases in the model that you trained on this data. So what we're also trying to do, and what I would recommend, is take a really deep dive in your data if you want to ensure there are no biases.
I do also remember a story of was it Facebook that were automatically rejecting female candidates' CVs about 2 or 3 years ago. And when they looked back on the reason why, I think the team was actually made up of like 20 males. So it wasn't that it was bias against females, because they were filling in what their history was. And it was actually taking people out. If it was things like captain of the female volleyball team, it was excluding candidates for those particular errors. So you've also got to think of the diverseness of your team when approaching these problems. So the second last question is from Rampton. It's a question for anybody. How the information which is extracted from an AI model, which is not personal data, is guaranteed not to be used for creating predictions or decisions over new patterns. It won't be used something like GDPR. Yeah, maybe Rampton, if you want to jump into the breakout area and maybe ask one of the speakers. And the last question is from Junli. It's out of Jenny. It's what do you think about the smartphone applications that will measure your body off an image shot?
Well, yeah, if we don't touch the privacy concerns that some customers, especially in Germany, would worry about, I think this is the way to go, and we could expect more and more such applications appearing in companies of different scales, including Zalando, because it's a good source of seamless data acquisition, I would say.
Excellent, fantastic. So that will conclude our event. So for everyone who is interested, make sure you follow. We're going to run events every 4 to 6 weeks on similar topics, panel discussions, and also look to add in some technical presentations at a later stage. So I'd like to thank everyone as well. My panelists, Najib, Furkan, Jenny, Depti, thank you. I really appreciate coming on and taking time out of your Wednesday evening to be a part of this and the very first SOTA Social Computer Vision in Production event. So if everyone has seen in the chat, we have a link to a Zoom. If you join the Zoom, that will be a breakout area. You'll be able to mingle with the other people who have attended the event and also the speakers. So I hope to see you there. But everyone else, have a great evening, and thank you for attending.
Thank
you.
See you in the networking.